Yeah, I welcome you all for this course, Design Analysis Algorithm. Uh, in this session, we'll see Unit 1, Introduction. In Introduction, we'll see the notion of the algorithm and fundamental of algorithm, then important problem types, and fundamentals of analysis and of algorithm efficiency, asymptotic notation and its properties, analysis framework, empirical analysis, and finally, mathematical analysis for recursive and non-recursive algorithm visualizations. Let's see what is an algorithm. So as we all know, an algorithm is a sequence of unambiguous instruction for solving a particular problem. So each algorithm have at least one input, and based on that input, we'll apply some techniques, that is sequence of steps we will apply on that input, and we'll get the desired output. So algorithm, as I specified, it's a sequence of steps, and it should be very clear. It should be unambiguous in order to solve a problem. This is what an algorithm. Then what is the difference between algorithm and pseudocode? So algorithm is a step-by-step instruction, well-defined step-by-step instruction, which is known as an algorithm. But pseudocode is nothing but, so it's an implementation of an algorithm without getting into the syntactical details. That is, so exact, if you are having on program, that program you are writing with syntax, but pseudocode doesn't have any syntax, but it describes how to implement an algorithm without any syntax. That is what the pseudocode. Then you know what is program and you know what is an algorithm. This is the simple difference between an algorithm and program. Program must be a syntactical one, and algorithm is a step-by-step procedure. So each programming language differs in syntax. Algorithm, you can write it in any natural language, but it's a step-by-step procedure to solve a problem. Then in this session, we'll understand the concept of prime factorization. So you all know what is prime number. A number is divisible by 1 and itself. This is what a prime number. Then what is mean by a factor? For example, if you have a number 6, the number 6 has two factors, that is 2 into 3. So when we are multiplying 2 with 3, we'll get this 6 value. Then the factor of a 6 is 2 and 3, right? Yeah, now what is prime factorization? Is finding which prime number multiplied together to make a original number. So for example, in 6 we have two factors, that is 2 and 3. In that, which prime number multiply together to make the original number, that is what the prime number. So for example, 3 in 6, in case 6, the prime factorization is 3. So prime factorization using the factor tree method and Euclidean distance method. There are two methods. So we'll see one by one. So this is the tree method. So for example, if we have a number 36, in order to find the prime factorization, so you have to split the number, or you have to factor, you have to start with any factor of the number 36, in such that you can find the final factorization number. So for 36, we can multiply 12 with 3, we'll get a 36. So that is the first, we can start with any factor. So this is the first factor, 12 into 3. Then again, we can split the number 12 into again one more factor called 3 into 4. So likewise, we can form a factor tree. So I repeat, for example, 36, in order to find the factor for 36, you start with first factor, that is 12 into 3. 12 3s are 36. That is first factor. And again, if it is possible, you can factorize the number 12. Again, 3 into 4 is 12. So we can factor. So likewise, we can form a tree. So as I displayed in the PPT, so this is what the tree, 36, 12 into 3, again 12, 3 into 4. So then, now circle the prime factors. Again, 4, we can factor like 2 into 2. So this is the final tree, 36, we can factor 12 into 3. Again, 12, we can factor 3 into 4. Again, 4, we can factor 2 into 2. This is the final factor tree for the 36. Now we can circle the prime factor number. Then we'll get 2 2s and 2 3s. It means that 2 power 2 into 3 power 2. This is the prime factor of the 36. 2 square into 3 square. So now I'll give one classwork problem. You can do it now. So what is the prime factorization of 48? Yes. So this is the prime factorization of 48 solution. So 48 again, we can divide it into 2 into 24. Again, 24 we can divide 4 into 6. 4 already we seen divided into 2 into 2. 6 already divided 2 into 3. So now circle the factors. We get 4 2s and 1 3. That means that 2 power 4 into 3. That is the prime factorization of 48. Likewise, we can do it for 147. Yeah, same method. We can use a factor tree method. Now we'll see what is the GCD of a number, greatest common divisor. So GCD of two non-negative integer m and n, denoted GCD of m and n, is defined as the largest integer that divides both the m and n. Largest integer that divides both the m and n. So if we take any two number, for example, 10 into 50, two non-negative integer, for example, 10 into 50, if you are taking, the largest integer that divides both 10 and 50 is known as a greatest common divisor. So in this case, we can take 10 as a greatest common divisor because the number 10 it divides the number 10 as well as 50. Okay, let's see one example. So again, for GCD, we have different methods. One is a prime factorization method. Already we've seen. We can split. For example, you take two non-negative integer 12 and 14. 12 we can use a factor tree method, and you can find out 2 square into 3 is nothing but 12. Again, 2 into 7 is 14. So what is the greatest common divisor in this? M and n? Yes, exactly. 2 is the greatest common divisor. So likewise, you can do it for m and n. M equal to 5, n equal to 10, GCD of 5, 10. What is the greatest common divisor here? Again, you can factor 5 with the help of factor tree method. So 5, we have 1 into 5. For 10, we can use 2 into 4, 2 into 10, 2 into 5. Yes, second method is elicit algorithm. In Euclidean algorithm, we can use a formula in order to find the GCD of a number. So for example, GCD of two non-negative number m and n, which is equal to GCD of number n, comma m mod n. So that is the Euclid algorithm formula. Now let's see one example you can understand very easily. Compute GCD of m and n by Euclid algorithm. Input we are giving to input as a two non-negative integer, and output we should get greatest common divisor for m and n. While n not equal to 0, do m mod n, that is the remainder. Then you have to swap m as a n and n as a remainder. Then again do the operation till n not equal to 0. So this is the procedure to find GCD of a two non-negative integer using Euclid algorithm. So let's see one example you can understand very easily. So I'm just taking 67 into 29. Then first step, you have to find the 67 mod 29. We'll get remainder is 9. As I said, n become 9 and n become remainder in second step. That is 29 comma 9. Again, Euclid 29 comma 9 is 29 mod 9, remainder 2. Now 9 comma 2 we are taking, 9 mod 2 is 1. Again 2 comma 1, 2 mod 1 is 0. So now the n becomes 0. We can stop here, and the output is 1. This is the greatest common divisor for 67 and 29. Okay, so likewise you do it for 29 comma 9. Also you can find it for the largest number like 31,415, 14,142. So if you use Euclid algorithm, it's very easy to find any largest number. So likewise you can do it. It's very simple only. You have to mod the number, and again n becomes m and the remainder becomes n. Again do the steps till n becomes 0. So that's all. How this is the steps to find the GCD of a number by using Euclid algorithm. Yeah, that's all about the today's session. So in upcoming session, we'll see about algorithm characteristics and algorithm problem types and asymptotic notations and so on. So that's all today's session. Thank you all. Thank you.